Hi everyone, welcome to the channel. So my name is Baptiste. I used to work at Hugging Face as a researcher in the agentic team, and now I've quit that and I'm starting this YouTube journey, and also I'm building my own agentic startup. So this week I'm trying a new format. I want to do like what's new in AI. So I'm thinking of it like a weekly video where I talk about like all the cool AI news because there's so much it's difficult to follow in like one format, so then you can be updated on what's new in AI. So this week I'm also actually doing like 2 weeks, so then I have a bit more content of like what's new in like the last 2 weeks in AI. So first it was a super big week for open weight models. So there was three open weight models: the Kimi GLM model and also the Minmax. So let me start by maybe this is my favorite benchmark. It's the artificial analysis. I really love it because I think it's they also do a lot of different like speech to speech. So every time I think it's just a great resource, and they spend a lot of time doing them. So those open weight model, of course, they are below Opus and Codex. So generally, it is the same. It's the same with my own experience. Is you have the GLM on top, and then you have the Kimi K2, and the min max is a bit below both of them. But then I have a surprising results about it. But based on my own experience, it's also something similar. So Kimi, what I really like about it is that it's a vision model. So it's really good, and you can bring screenshots of your like you're building like a web app. You can bring screenshot of that, so debug it like live with the true like vision capability. I've also seen that models that have vision are generally better at front end. So Kimi, based on what I've seen, is as best in class for like out of those three for any front end design. It's much better than the other two, and I think this is also like due to this vision component. Then GLM for me it's amazing. It's best in class in this time of three open weight. It really can do like long horizon kind of refactoring and development. So it's really a lovely model to use. One interesting fact that is also what I've seen personally, but put in result is that generally like front end is a much easier. Like end-to-end correctness, it's at 75 compared to back end, and this is a bit similar of what I've made my own experience. So when you ask often to work in the back end, then the AI will like kind of add a lot of like fallback logic instead of just like making like a clean, simple architecture. Will add a lot of fallback logic, a lot of like nested if statement, just add on top instead of just like rewriting it to be like the essence of what you want of just clean architecture. And it's you have to not necessarily fight the model a lot, but be a lot more strict. And I have actually a lot video coming up on like in agentic engineering how to do testing. So this kind of like vibe testing or agentic testing, I think that's a really important part. And a lot of people create a lot of code, but they don't. But the problem is you have to keep this code working in production. You have to have testing. You have to have some restrictions, some guardrails for the AI to not go crazy. Because indeed, you see, this is still quite low, and it's not 99% efficient. So you have to find way to bring that efficiency to make the model a lot less able to make mistakes. And then the min max, so it's really nice. Also drop the cost, the performance. It's quite still above compared to last generation. What's really interesting is for min max they open hand, so it's a harness for coding, and min max is the best in class there. So what open hand does is similar to like Devin. you can embed open. Now they're going to that direction, open embedded into your application, but you can like ask OpenHand to do like peer review. You can ask him to like implement some change. So it's a really famous repository, like open source repository. So they have a CLI, and this so is similar to Cloud Code and Codex. And there, the performance of MinMax is best in class. What I thought was interesting is that maybe so you have the similar idea for open code. Is open code you have sometimes you have free models, so I'm using that in my product, but you have free models that are available for a limited time because the team is actually collecting traces and then doing RL on them to increase the performance. So this is maybe what they did in OpenHand. That's why they also have this maybe featured post with them. And I suspect that Kimi and GLM, which is not even mentioned, didn't do that. So maybe that's why also they have a drop in performance, because they could just like give the model a better understanding of the harness. And this is what all the labs are training, and they're training on the most popular harness to optimize tool calling there, to optimize the traces, and to make sure that even if there is a weird like uh, unexpected behavior from the harness, that doesn't like decrease performance too much, because sometimes the harness, they don't make the same assumption as like Cloud Code or Codex, so then the AI is completely thrown off course because it has only been trained on a certain harness. So that's really what they are doing, and this is why you have super lucky you have those kind of free models available. On those three, you also have like they all have a coding subscription. So there you have the Kimi CLI, you have the GLM plan, which is really lovely plan. And what I really like about it is that out of those provider, the only one that allows you to use their coding plan in open code, which is for me the best CLI, like Cloud Code, Codex type of CLI. It has a lot of star, and it's done by X like Vim user, and it's a really lovely product. The only one that allows them to use their coding plan is the GLM, and then you can also use the ChatGPT coding plan, but at least from like open weight, you can use GLM, and they're extremely cheap compared to the usage. So they really like trying to like say, okay, compared to Cloud Code, we are a lot 3x the usage, 4x the usage. So it's a lot of like it's a lot of tokens that are extremely cheap. So that's really nice, and it's available in open code, uh, which is uh, which is lovely, of course. And now, let me change a bit of subject. Let me talk about OpenClaw. Sorry. So OpenClaw is the project from Peter Seinberger, which has really taken off. So if you look at OpenClaw, I mean the number of stars is crazy for such a small amount of time. So that's like a 3 month project, and it ships continuously. And so he's joining OpenAI. So they were in discussion with you had the Lex Freeman podcast where it was in discussion, Peter, between joining OpenAI and Meta, and he decided to join OpenAI. I mean, kudos to him. I think it's a great project. I think OpenAI, they have a lot of cool research and they can really help bring this into market. So really interesting to see like such a rapid ascent, and now it's going to move to like OpenAI. So I'm curious. So one of these conditions was it has to remain open source, the harness, but I think a lot of harness are remaining are becoming open source. So the Codex harness is open source. The Gemini one is open source. So you have access to all those. So they want to do the same with OpenClaw, and then allow everybody to have their own personal assistant, which is really lovely. Then you see a lot of companies that are built on OpenClaw. From YC, they have a lot. So for example, this one that live in Slack and that can do tasks. You also have this one, which is allows you to like deploy OpenClaw extremely rapidly. because right now it's a nightmare to set up. You also have, which is the approach I'm taking, more of like a rewrite of OpenClaw, which is like, okay, the concept is really cool. Maybe there's some stuff I want to do differently. So what they do here is they have like uh, containers by default, and actually not having this kind of unsecure mode, which I think it prevents a lot of headache in the long term. And having this kind of clean environment that you can maybe dispose and recreate, that's so really nice. So that's the direction I'm taking. So Nano Claw, it's also inspired by like Nano ChatGPT and those kind of Nano Llama, those kind of small projects. So I think now they don't mention it anymore in the repo, but at least in the beginning, I think it was the agentic loop was like 1,000 line of code, which is really really nice to have that. And then I have BAP, so this is, you can follow. It's my other videos, but it's my own like own agent that allows me to automate different work. So saying get my emails and send an email or get data from Airtable into my Notion, etc. So so I'm building something similar to OpenClaw. I'm really building it in public, so I'm sharing my learnings. It also forced me to learn a lot about like this own ecosystem, thinking about like how do you make, what's a good sandbox, what's good memory, what are the different options for harness and so on. And this is like, you can see my product update, but I won't bother you too much now. Um, One thing that I thought was interesting is so this is from I've this are two blog posts. Yes, one from, I lost my other blog post, from Harvard study, but saying that there is a big shift in cognitive, uh, like the load of a software engineer. So you have a lot of, before, like having to have this technical depth, really having to code all day, and now you have this cognitive depth because you have to manage like 20 different agents running in parallel. When a session finish, you have to start, you create another one, working on the next, and just the speed at which you're building software is so fast that you indeed have to shift a lot. The job is completely changing. So that's really interesting. And I think there was an Harvard study also saying saying something similar, that there is a lot of it's taking a lot of time and that it's putting a lot of stress on workers. So it's really interesting that the job is changing and that people are not expecting it. So even me, like I see the Codex app now, it's really shifting a lot of how I work. We also talk about like the Codex app and like tips and tricks there, but it's really interesting because before I used to manage like 20 different terminals, and now I, with the Codex app, it's a lot easier to, it reduces a lot of the cognitive load, just because with a GUI you can have a lot of nicety that allows you to keep track of everything a bit in an easier manner, and allows you to keep shipping. Um, then another post that I thought was really interesting was this one about audio AI. So I think audio AI, it's an area I've explored in the past, just personally for my own projects, and it's really cool because indeed it's really under like developed by the big labs. So the big labs, they are all going on agentic, which I think it's a huge market, but there is a small like number of like audio AI startups. So for example, Suno, they train like the first on like really like they didn't have a lot of GPUs. I think it was called Suno Bark, GitHub. So they created it in the open, and then they managed to find like product market fit, and then they really launched it. But what's interesting is this could have been dominated by OpenAI, but it wasn't. So this talk a bit about more the dynamics of why it wasn't dominated by those big labs. So one is just it's not a main focus for them. So Suno, they're gonna focus on music and they're gonna make it best in class. Compared to OpenAI, even Sora, it's not the top priority. The ChatGPT is the top priority. So having like one AI one AI company per vertical. So having like one being really focused on video, being really focused on text and reasoning, being really focused on audio. This actually quite a lot of weight to it, this argument. And this is exactly what this article is talking about. So this is um, a lovely lab in Paris. They do a lot of core research, and this was started really by like engineers, because what the article really put forward is that you have to have this engineering mindset to you have to have this research engineer. You really have to have people that will implement, because audio is a lot different from like text, in the sense that those people, for example, some were like DJ, so they understand like audio. They worked in like like what's the audio codecs, and that's actually quite technical. You have to think about amplitude, Fourier transform, and I remember my Fourier transform from university, and I mean it's okay, but it's not something I do on a day-to-day basis now anymore. And those people really have to think about all of those kind of really yeah, is it now the engineer were in charge of really the nitty and gritty details on how do you implement like an audio AI, because it's really specific audio, and you have to have a lot of domain knowledge, and this is where those small labs can really go faster. And also you don't have like this kind of necessarily like large easily downloadable like corpus, so you have to do a lot of more engineerings to make that work. And it says okay, there's actually a lot of you have a lot of small layer when it comes to come to voice come to audio. Now is the last part of my video where I just talk about some cool papers. So this one I think was a really lovely paper from like Quen and other like other player, but they tried it on I told you they also tried on Quen, but I think on some GPT-2 model. So they're really trying to optimize like training dynamics. This is really interesting because normally you do more of like static like filtering. It's more like static. You do like a filtering before checking like okay, what's gonna enter my model, and then maybe also the ordering, you do that in a static matter. And this is actually okay, let's just having like this training dynamics and having this data section on every iteration. So this allows you to really not have this kind of misalignment, how they call it, and being a lot having a much better direction when you want to go and reach your minima, because otherwise you might miss it. So they achieve yeah, a 2x perform plus 2 points average performance, and then 8x efficiency. So it's really interesting when you train large model, is that how do you select your data? Right now there's not a lot of thought put into it, but how can you select your data? It's like a low hanging fruit that can have a huge impact. And yeah, I've seen other research into that, into like curriculum, which is not exactly the same topic, but yeah, the order of your data has a lot of impact. And I think that was a really cool. So it's quite math heavy when you look into it, but they had great results. So I'm curious to see if that's going to be, I mean, clearly they're going to be applied at Alibaba, and I think other lab are probably going to look at it and pick some ideas from it. But always it's nice to look at like cool research and efficiency. On a more fun note, I think this was a fun paper. So you have this kind of Prism from OpenAI, which is a tool that allows you to more or less edit your latex, your research paper to text. And this is an agentic, it's an agent for illustration. So what it does is it takes the content of your paper and then through some like an agentic loop, create illustration. And it's really interesting because I think that's really like more like esoteric and a bit outside of what's usually done. But it's really cool because you see a lot of like illustration really being, it's really something important for scientific paper, and this make it easier and for everybody to use it. So it's really interesting to have like those kind of uh, more domain knowledge into how do you make a good scientific illustration. So they have a whole lot of method on how they generate like this refinement loop, and how do they generate this final illustration that best illustrate the paper. And so this is quite a general method, and then it could be applied to other industry when you need an illustration, when you need maybe like a presentation. And so it's cool to see those kind of agentic loop that are a bit more like outside just coding. And this is exactly what this paper is about. So that was quite cool. So, and I think that's it for me. So thank you very much for tuning in. So feel free to leave a comment below if anything wasn't clear, if you want to discuss anything further in the comments. I answer every comments because I have a small channel for now. And I think it's always nice to answer comments. And if you have also subscribe if you want to follow along. I have a lot of video plans on what I'm doing with my own project, how I'm using those AI tools, and yeah, thanks very much. See you, bye.